Hello and welcome to my science tutorial, and in today's video we are back with a brand new video on cycle theory. So without further ado, let's get started. So in today's video we want to look at cycle theory, and then cycle theory, like the name implies, they are theories of a cycle that holds true if we try to verify them ourselves. So everything I'll be explaining over here, assuming you take your compass and then you draw everything I said, and then you try to measure the angles, you find out that these theories are true. Okay, so let's have a look at the first theorem. So the first theorem is telling us the angle subtended by a chord at the center of a circle is double the angle subtended by the same chord at the cycle or the circumference of the cycle. Now what this basically means is this from here to here, the line drawn from here to here is a chord. Okay, now the longest chord that passes through the center is called a diameter. So this is also a chord, this is also a chord. Okay, now this is our center over here. Now what the theory is telling us is that if we have a chord and it has an angle at the center, and this same chord has another angle touching the circumference, then the angle at the top of the circumference over here, the angle over here, is twice the angle over here, or 2 times the angle over here is the angle over here. Okay, so it means whenever we have an angle over here, if we multiply it by half or we divide it by 2, then we should get the angle over here. Okay, so an angle subtended by a chord at the circumference over here, at the center is twice or double the angle subtended at the circumference of the cycle. That is what the first theory is telling us. So you need to familiarize yourself with the theorem so that you can be able to solve any questions that comes on cycle theory. And then this is the first theorem that we'll be looking at in our video. So let's have a look at the second theory. Now the second theory is telling us the angle subtended by a diameter at the circumference of a cycle is always 90. So if we have point A, point B, and then the line passing through the center of the cycle, okay, which is the diameter over here, any angle it subtends at any part of the circumference of the circle, the angle over there is 90 degrees. Okay, so assuming this diameter has an angle over here, let's say somewhere over here, and it's connected to this side, okay, the angle over here will also be 90. It doesn't matter any point on the cycle where the angle is located, okay, it's always 90. Once it is not a chord, it is a diameter and it has an angle at the circumference, then it is 90 degrees. So let's take note of that. Now the third theorem. So if angles on a circle are subtended by the same chord, then the two angles are equal. So if we have the same chord having the same angle, okay, the same chord bearing an angle at the circumference, and then the same chord we have another angle at the circumference again, so the same chord having two angles at the circumference, okay, subtending two angles at the circumference, then these two angles are equal. Okay, it doesn't matter, maybe we have this over here and then we may have the second angle very small somewhere here coming down here, the two angles will still be the same. It doesn't matter the part from here all the way down here where the second angle is located. Once it is subtended by the same chord at any point on the circumference of the cycle, those two angles are equal. So let's have a look at the fourth theorem that we will be looking at over here. Now let's take note of something. Can we see these two lines over here? This means the length of this chord and then the length of this chord are equal. Okay, so with that in mind, let's look at the theory. So it's telling us angles subtended by equal chords have the same size or are equal. Okay, so this chord is equal to this chord. Okay, so any angle they will have at the circumference of the circle, any part of the circle, those two angles will also be equal. All right, so let's have a look at the fifth theorem in this case. So it is saying if a quadrilateral is cyclic, which means we have a four figure shape, okay, and it is embedded in a circle, okay, then the opposite angles are supplementary, thus they add up to 180. So what do we mean by opposite angles over here? So we mean the angle over here A and then C, if we add them, they should be equal to 180. So if we add A plus C, it should be equal to 180. If we add B and then D, it will also be equal to 180. That is what this theorem is telling us. If you doubt any of this, just draw a circle, then you just draw 4 chords anyhow, then connect them, okay. Measure the angle over here with protractors, measure the angle, then add the opposite angles and see whether they will not be nearly almost equal to 180. So if you do this very well, we know there is human error with everything we do. So if you do it very well and then you measure the angles, you may be getting something like 178, 179 degrees, which is almost equal to 180. Taking into consideration our errors, then it should be almost equal to 180. Okay, the same holds for every theory that we have over here. If you think it's a lie, all you have to do is just to draw the circles yourself, draw the chord, and make sure you draw everything as you see over here, and then exactly you'll be getting what I'm saying. So over here you'll be getting like the angle you have over here. If you multiply it with 2, you get this one. Then the angle will be 90 if you draw to like a scale, or if you are not accurate, you should be getting like 88 or 89 degrees Celsius. That should tell you how close you are to the true value. It is 90 over here, okay. And then this one, you also get to know that this angle and this angle are equal, okay. So that is how true circle theory is, okay. So I will entreat all of us to dare and then draw these circles and then draw everything as we see over here, and then try to measure the angles and see if what I'm saying is true. Now the sixth theory, which we have over here, is telling us the angle between a tangent to a circle and a chord drawn from the point of contact is equal to the angle in the alternate segment. Now all that this whole English is telling us is, whenever we have a circle, then we have a chord, okay, and then we have another chord, we have a tangent, sorry, this is a tangent, then we have another chord, okay, having a triangle inside, okay. The angle subtended by this tangent to one of the chords, which is the chord over here, okay, is equal to what? The angle in the alternate segment, okay. So we can say that this is alternating angles, like we normally say they are in the form of Z, okay, they are in the form of Z, okay. So if this is the chord and then this is the tangent, okay, then the angle in the alternate segment will be this if you try to draw the Z over here, okay. So assuming the angle is over here, okay, if it is over here, then you try to draw the Z, okay, then it will also still be here, something like that, okay. So whatever we are saying is the angle that the tangent is bearing to the circle, okay, that angle will be equal to the angle in the alternate segment, okay. So this is some few examples, and then there is another one that we actually don't have over here, but then it also follows this same thing. So whenever we have a circle and then we have a tangent, okay, and then we have a diameter, okay, so we have a diameter touching the tangent, okay, the angle between the diameter and then the tangent is 90 degrees, okay. So if the diameter is from here to here, and then we have the tangent over here, the angle between the diameter and then the tangent is 90 degrees. So with these few theories in mind, let's look at some few examples to actually appreciate what we mean and then what we are saying over here. So I've prepared 3 examples for us, so let's get started and then let's see what we can do. So the first example, we have let me name here A, B, and then C, so that we can use them to actually name the angles. So we have over here, we have angle, let's say here is O, angle AOC, which is AOC, the angle over here, which is equal to A, is what? Unknown, we don't know it, okay. Now angle ABC, which is the angle A, B, and C, is over here, which is 62, that we know. Now from the first theorem that we learned, we know that the angles subtended at the circumference over here, okay, twice that angle is the angle that is subtended at the center over here, okay, or the angle subtended by a chord at the center is twice the angle subtended at the circumference. So from here we know that what we know that the angle we have over here, which is angle AOC, is equal to twice angle ABC. Now if this holds true, then it means angle AOC is equal to 2 into bracket 62. Okay, so angle AOC is equal to, now 2 times 62, 2 times 62 will give us what? 124. Okay, so the angle we have over here, which is the angle over here, is what? 124 degrees. Let's have a look at the second example. Here we have to find the angle V and then A. So let me have here O, A, B, C, and then D, just something to denote those points. So over here we can see we can assume this, okay, not assume per se, but then there is a chord over here. There's a chord over here. Okay, so from here we can see something, some of the theories being visible over here. So we have a chord, okay, and then it has an angle at the center over here. So angle AOB, yes, is equal to what? 81 degrees. Okay, so angle ACB, okay, which is equal to what? A. Okay, we don't know, but then we know that this angle over here, angle AOB, is equal to what? Twice the angle AOB is equal to twice the angle ACB. Now we know angle AOB to be what? 81 degrees is equal to what? Twice angle ACB. Okay, sorry. So all we have to do is what? Divide by 2. So yeah, so we now have angle ACB is equal to what? 81 divided by 2. Let me punch that quickly. We have 40.5. So 40.5 degrees. So it means angle ACB, which is the A over here, is what? 40.5 degrees. Now can you see this same chord is having an angle at the circumference? This same chord has another angle at this side of the circumference. Okay, so from the I think that is the second theory, we can see that angles subtended by the same chord at the circumference are equal. Okay, so angle ADB, which is the V over here, is equal to what? Angle ACB. Okay, now if this holds true, it means the angle ACB we have over here, okay, is 40.5 degrees. So it also implies angle ABD is also what? 40.5, which means the A is what? 40.5, and then our V is also equal to what? 40.5. Okay, let's have a look at this example. Now if we take a critical look at it, this is the angle over here. So let me have that over there. Now we can see there should be a chord here. So the question is not given, but we can draw that ourselves. Okay, so let's see what we can do with this example. Now we can see that this is the diameter. Okay, this is the center over here. So let me have here A, B, C, D. Line AC is the diameter. So we know that the angle subtended by a diameter at the circumference is 90. So it is telling us the whole of this side is what? 90 degrees. So angle ABC, which is this, okay, is what? 90 degrees. And we know this side to be what? 66. Okay, so we know angle ACB is what? 66 degrees. Degrees. Okay, now we know angles within a triangle will add up to 180, so we can simply solve this. So we can have 66 plus 90 plus the h we have over here, h is equal to 180. So h is what? 180 minus 90 plus 66 will give us what? 156. So our h is equal to what? 180 minus 156 will give us what? 24 degrees. So it means the angle h over here is what? H is what? 24 degrees. Okay, now this angle and this angle, the a over here, you can see that there's a chord over here. This chord sustains this angle at the circumference. This same chord is sustaining the angle a over here. So literally this also means what? Angle angle CBA. No, this angle over here. So angle BAC. So angle BAC is equal to what? This angle over here, which is BDA. So angle BDC. Okay, so since h is what? 24. Okay, since h is 24, it means what? Our a is also what? 24. Okay, so yeah, this is some few example about circle theory. Now let's have a look at another interesting one, which is a bit complicated a little, so that we can appreciate what we are doing. Okay, so example number 4. Okay, beautiful. Now example number 4, let's label this part maybe I, and then here will be K, then here will be J, and then here will be L. Okay, so from the look of things, we have to find the angle H over here, and we know from I to J is what? The diameter. So that is technically telling us the angle over here, the entire angle over here should be 90 in the first place. So we should take note of that. So we know angle what? IKJ should be what? 90 degrees. Now if angle IKJ is 90 degrees, then that is telling us then angle IKL, which is IKL, let me use another color for that. The angle over here from here to here, just from here to here, which is the IKL, will be equal to what? 90 minus the 38 over here, which is giving us what? 52 degrees. Okay, so if this is 52 degrees, then we can say angle I, or here is the center, so O. So angle IOL, we don't know. So the IOL over here, which is this one, we don't know. Okay, but then angle IOL is equal to, now we can see this is a chord having an angle at the center, and this same chord has another angle at the top over here, which is the one that we just find to be what? 52. Okay, and we know the angle over here, okay, at the center, which is the IOL, is twice the angle which is IKL. Now that we have IKL to be 52, angle IOL is what? 2 times 52, which is giving us what? 104 degrees. So here is 104 degrees. Now if this is 104, and then we have our angle H over here, now we know the H, okay, then we have to find we have to find this angle, so as we can add this angle, and this, the H, to get should be equal to 180, so that we get our H. So we can see, let me use another color over here quickly. We can see this looks like a chord. Okay, this can be a chord. Okay, So if this is a chord, then we can say that this chord over here is having an angle over here, which is the 38 over here. Now this same chord has another angle over here, which is the one that we don't know over here. So angles are stated by the same chord at the circumference are equal. So if this is 38, it means this is also what? 38. Okay, so it means the angle JIL is also what? 38. So from here, what do? We say what? This whole angle within this triangle over here will give us what? 180. So we have 38 plus 104 plus h is equal to what? 180. Okay, so it means h plus 38 plus 104 will give us what? 142 is equal to 180. So our h is equal to what? 180 minus 142. So our h is what? 38 degrees. Okay, so our angle over here, h, okay, is actually what? 38 degrees. So yes, this is how we solve circle theorem using the theories that we've studied so far. Now when you are solving circle theorem questions, try to like be imaginative, try to be dynamic as much as possible. Okay, so if possible, tilt the paper. Okay, like what I did over here. Okay, I had to like say this. Okay, there is this, connecting this is a chord, and then I can see that okay, it has an angle over here, it has an angle over here. Okay, so try to see the circle from any angle at all. So you can see from this angle, see from this angle, see from this angle, maybe probably this angle or this angle, or any angle at all that you can see the circle from, and notice some of the theorems inside so that you can use to solve the problem. Try and use them. And also don't forget your alternate angles, your corresponding angles on a straight line add up to 180, or everything that about angles that you know, okay, about a straight line or anything, apply them, and then you'll be able to solve any question on circle theorem easily. So thanks you guys for watching, and then I'll see you in the next video. And then if you are new to this channel, kindly consider subscribing, as we post tutorial videos every single day. So thanks you guys for watching, and then I'll see you in the next video. Bye bye.